estimating versus rounding. What's the difference in a math connotation, and also what's the difference in real life? Today we're going to talk about it. We're going to talk about how they're alike and how they're different. The easiest thing to differentiate between estimating and rounding is to think about what you estimate. You estimate sums, differences, products, and quotients. And if I were to ask you what these have in common, it's that they are the answers to addition, subtraction, multiplication, and division problems. That's an estimate. In order to get an estimate, you round the addends to get an estimated sum. You round the minuend and the subtrahend to get a difference. You round the factors to get an estimated product. And you round the divisor and the dividend to get an estimated quotient. So hopefully you're seeing that in order to get an estimate, rounding is involved. Rounding is done to a number. Estimating is done to an answer. A test question might say, round this to the nearest whole number. And there is only one correct answer. If I'm rounding to the nearest whole number, that's the same as rounding to the nearest integer. And I know that 357 and 9300ths is between the integer 357 and 358. And the one that it is the nearest is 358. So when you are asked to round on a test, there's one correct answer. But when you are asked to estimate, it just simply says estimate the answer. There's going to be more than one answer because estimating is what makes it easy for you. And what makes it easy for you may not make it easy for the person beside you. Some of you may be able to estimate this as 38 plus 65 because you can do that mentally. Others may choose to call that this is 40 plus 70 or even 40 plus 60 because those are compatible numbers. So I may say my estimated answer 40 plus 70 is 110. You may have estimated it to be 100. Estimating means round each part and get an estimate. Rounding is a specific place value. So, some estimating strategies. Probably the one that's used the most is to round to the greatest place value. When you round as far left as you can go, when you round to the greatest place value, you're left with numbers with zeros. And typically zeros make the four operations easier to do. Sometimes it's easier to round with compatible numbers, numbers that just specifically go together. An example might be if you were asked to estimate this. Well, 56.9, if I were going to use rounding, rounds to 57. And 7.8 rounds to 8. But those numbers aren't compatible. Numbers that are compatible would be if I left this at 56 and then divided it by 8. So an estimate of 7 is a good estimate. 15.5 plus 6.798. 15 and 5/10 plus 6 and 798 thousandths. 16 and 7 is what I could round it to. And if I'm able to do that in my head and get 23, but it may be that I want to round this all the way to 20. And 20 plus 7 is 27. So again, when you're estimating, you can use compatible numbers or you can round to the greatest place value. So, let's practice. We'll pick a strategy and notice the directions on this. It says estimate each answer, then solve. 19 and 5/10 is 20 plus 292 and 35/100. I'm just going to round to 300. So my estimate is 320. Now the directions say estimate each answer, which is what I've done. This is my estimate. Then solve, which means it actually wants me to go back and solve this problem to compare it to my estimate. 292 and 35 hundredths plus 19 and 5 tenths. 311 and 85 hundredths is what I got for this answer, compared to 320, which is what I got for my estimate. Let's do the same with subtraction. 15 and 3 tenths minus 3 and 75 hundredths. What is 15 minus 4? 11 is my estimate, so I have done only the first part of the directions. In order to complete the second part, I must actually solve it. And for this one, I'm going to use the counting up subtraction strategy. If I'm at 375, I know that 25 cents will get me to $4. And then I know that 11 and 3 tenths will get me to 15.3. So the answer is 11.55. All right, 95 times 37, 100 times 37. Those are compatible in my head, so I can know that this answer should be 3,700. Clear this, and again, we're going to follow these directions to solve. 95 times 37. In order to multiply, 5 times 7 is 35. 7 times 90 is 630. Plus 3 is 660. 30 times 5 is 150. 30 times 90 is 2,700. 2,800. 3,515 is close to my estimate of 3,700. And then finally, 105 divided by 22. Compatible numbers means numbers that work in my head. This would be 100, and I could round this to 20 because that would work in my head, or I could round it to 25 because I know there are 4 quarters in a dollar. So now let's see how estimating can help me solve this. My estimate is 4, so that's where I'm going to start. 4 times 22 is 88. So I have 4 and 17, remainder 17, which can be written 4 and 17 22s. So even an estimate can help you do subtractive division a little easier. All right, estimating versus rounding. Let's see what you know. Ruth goes to the mall and buys her daughter a $57 pair of shoes, a $28 shirt, and a $45 outfit. Her total bill was $130. When she gets home, her husband asks what they spent, and she replies, about $100. Did she round, or did she estimate? Before you answer, let's do the next one. A husband and wife go shopping. Each time they put an item in the cart, her husband does some mental math. When they get to the register, he challenges her to guess the total before the cashier tells them what it is. He guesses correctly. She loses. Can you figure out why? Is it an estimate or is it rounding? These two situations very much describe the difference between estimating and rounding. In this, she knew the total was 130, so it was not an estimate. It was rounding because she rounded it to 100. In this one, when he was doing the mental math, he was rounding each item so that he would have an estimated total at the end. estimating is what we do to get answers. Rounding happens to individual numbers.